I will work through the Unit 2 review with you all. So please bear with me as it might take a minute to explain most things. So it might be very lengthy. But in Unit 2, we talked about logic and proof. The first question says, write the hypothesis of the statement. If you are President of the United States, then you are older than 35. So the hypothesis follows that word if. So it would be you are President of the United States. That's it. So when you write it, do not include the word if. Again, the hypothesis follows the word if. Do not include the word if. Number 2, write the converse of the following statement. If it's a cat, then it meows. If you recall from our notes, converse is when you take Q and P and you switch them. So it would be if Q, then P. So if I were to take this statement and break it apart, P is it's a cat, Q is it meows. So now when I write my converse, I'm going to write it so that Q comes first, sorry. So it would read, if it meows, then it's a cat. Number 3 wants us to identify the inverse of the statement below. If it's an isosceles triangle, then it has two congruent sides. So first, let's identify P's and Q's. So P is it's an isosceles triangle. Q is it has two congruent sides. So when we write our inverse, we gotta remember inverse is not P, then not Q. So by our verbs in P and Q, we have to add the word not, as it's not already there to begin with. So let's read choice A. If it does not have two congruent sides, well, two congruent sides was part of Q. Again, the sentence has to start with not, if not P. So that's why we're not going to look at choice A. All right. B says if it is not an isosceles triangle, so far sounds good. Let's keep reading. Then it has two congruent sides. It has two congruent sides was already Q. It was so that's not that's incorrect as well. C says if it has two congruent sides, again, that's Q. The sentence is supposed to start with P, but add the word not. So we can't use C. So our option by process of elimination would be D. If it is not an isosceles triangle, then it does not have two congruent sides. So this is our answer choice, D. You got to make sure if it's multiple choice that you read the entire sentence carefully. Don't just go with the very first words you read and it's the right thing that you want to hear. You must read the entire sentence. Number 4 wants us to identify the contrapositive of the following statement. So the first thing we're going to do is identify our P's and our Q's. So if Sandy did not get a haircut, then she has split ends. So Sandy did not get a haircut, that's P. she has split ends. That's Q. When we write our contrapositive, we write it as not Q, then not P. So let's look at Q. Q says she has split ends. So we're going to have to put not inside of that statement or that portion. If you look at P, it says Sandy did not get a haircut. So that means we're going to have to take not out of it if we're going to write a correct contrapositive. So let's go through our answer choices and see which one is the best for this scenario. If Sandy does not have split ends, so far so good, then she did not get a haircut. So we didn't change P at all. That's what P said. That means Q comes first in A, but it didn't change P. So we need to cancel that one. B says, if Sandy did not get a haircut, that's exactly what P said in the beginning in the original statement. Again, when we write the contrapositive, we want Q to come first. So we're going to eliminate choice B. C, if Sandy does not have split ends, so far so good, then she got a haircut. So that is both not Q and not P in the correct location. So our answer is C. Number 5, which statement is logically equivalent to the conditional statement? When we gave the notes originally, we mentioned that the contrapositive and the conditional statement are logically equivalent. What logically equivalent means is that they would both have the same truth value. So if one is false, the other one will be false. If one is true, the other one will be true. So again, the contrapositive and the conditional statement will always have the same truth value, so they will always be logically equivalent. Number 6, when is a biconditional statement true? The biconditional statement was the statement that we wrote when we the biconditional statement was when we used if and only if in the middle. A biconditional will be true if the conditional statement and the converse are true. In other words, you have to read it forwards and backwards and it still be true. Then the biconditional is true. Number 7, which of the following statements can be written as a true biconditional? So you look at your answer choices and you see that all of these are conditional statements. So we have to see which one of these are true conditional statements, and then we have to read it backwards and see if it's a true converse also before we can say that it's the answer we're seeking, a true biconditional. So let's start reading our choices. If today is Christmas, then it is December 25th. That is a true statement. Christmas is December 25th every single year, no matter what day it falls on. That is a true statement. So read it backwards. If it is December 25th, then it is Christmas. That is still a true statement. So that means answer A would be a true biconditional. Let's just entertain the rest of the choices and I'll show you why they won't be a true biconditional. Read B. If an angle measures 32 degrees, then it is an acute angle. Well, we learned earlier this year that acute means less than 90. So yes, that is true. However, if you read it backwards, it sounds like this. If it is an acute angle, then it measures 32 degrees. So that's not necessarily true. You could have acute angles be 10, 15, any number that is less than 90 degrees, but larger than 0. So in order to say true, it has to be true all the time, no matter what. As soon as you say, well, maybe sometimes it could go like this or that, then it's false, ladies and gentlemen. So again, in order to be true, it has to be true every single time. Number 8 says, which of the following is a true biconditional? So again, now the answer choices are written in biconditional form, but we would have to break it apart and think of it as a conditional statement and a converse statement before we can determine if it is true. So let's get started. Choice A says an angle measures 132 degrees if and only if it is obtuse. So when I read it forward, if the angle measures 132 degrees, then it is obtuse. That is true. So the conditional is true. Let's read it backwards. If an angle is obtuse, then it measures 132 degrees. Now, we just kind of touched upon that in 7. That's not necessarily true. The classification for obtuse means just larger than between 90 and 180. So the 132 is not the only thing that fits in that range. So that's why we have to eliminate choice A. Choice B says an angle, I think that should have said a figure, not an angle. So excuse that typo. But let's use figure. A figure is a rectangle if and only if it has 4 sides. That is a true statement because we know rectangles have 4 sides. But read it backwards. If it has 4 sides, then it is a rectangle. Is that always true? No. It could be a square. It could be a kite. It could be a trapezoid. So we have to eliminate choice B. Let's read C. Babies cry if and only if they're hungry. Right away, if I wrote the conditional, if babies cry, then they are hungry. That's not even true. The conditional is not true. Babies don't just cry when they're hungry. They cry when they're wet. They cry when they're cranky or tired or have an upset stomach. There's other reasons that they cry. So simply being hungry is not enough. So that leaves process of elimination, choice D. A figure is a triangle if and only if it has 3 sides. So if a figure is a triangle, then it has 3 sides. Yes, that's true. Read it backwards. If it has 3 sides, then the figure is a triangle. That is still true. So again, in order to be a true biconditional, you have to be able to read it forwards and backwards, and it still be true. Number 9 wants us to use our laws of syllogism or detachment to prove that the conclusion is valid. So the first given piece, it says, if a triangle has 3 congruent sides, then it is an equilateral triangle. So first of all, let's label our P's and Q's. So P is a triangle has 3 sides, or 3 congruent sides. Q would be it is an equilateral triangle. All right. the second given statement, if it is an equilateral triangle, that's Q, then it has three 60-degree angles. So we haven't talked about 60-degree angles before, so that's some new information. So that would be R. The conclusion reads, if a triangle has three congruent sides, that was P from above, then it has three 60-degree angles, that was R above. So it's following the law of syllogism, because law of syllogism says P then Q, Q then R. So your conclusion will be P then R. So syllogism is our answer. It has to follow the pattern to the letter. Can't stress that enough. It has to follow the pattern to the letter. All right, number 10. Again, we're doing the same thing. So let's get started on labeling our P's and our Q's. So if the sum of two angles is 180 degrees, then they are supplementary angles. So P is the sum of two angles is 180 degrees. And then they are supplementary angles will be Q. Then it tells us specifically that angle A and angle B have a sum of 180 degrees. So we talked about the sum of 180 in P, so this is P. Conclusion, angle A and angle B are supplementary. We talked about supplementary in Q. So this is following the law of detachment. Right away, you should notice that from the patterns above, you need some new information in order for it to be syllogism. So we don't have that new information. And then detachment follows the pattern P, then Q, P, and then the conclusion will be Q. When you see detachment, also the first statement will always be very general or broad. And then the second statement will be more specific. But when it's specific, it has to tie back to the hypothesis or to P in order for it to be law of detachment. I'm going to take a break right here and resume back with problem 11.